All right, so new scenario. I would imagine this is new for most kids. What do you do if you have a trinomial, and you got the x squared, the x, and the constant, but that a value is not 1. So you have a number in front of your x squared and you can't do anything to get rid of it. There is a trick we can use, and it's called factoring by grouping. Now, there's other tricks, there's other different methods, but essentially it all is the same concept. We are looking to group, and you'll see what that means once we go through an example. All right, so in this example, you can see that your a value is definitely not 1, so you can't just do this thing where you make your x and then you put your c and your b value in. That shortcut's not going to work because the criteria is not met. So that's off the table. What we can do, and actually what I want to do before we even get started, is this should say +5, so that is a typo, and that's going to change the game. So we need to change that to a +5. All right. So what we're going to do is we're going to multiply our a and our c term. All right. So your a would be 6 and your c would be +5. So I'm going to draw my x, but instead of just putting the c term at the top, I'm going to put a times c. So 6 times 5 is 30. All right. I need to find two numbers that multiply to get me that 30, but they also have to add to get me my b term. So I still put my b term at the bottom. That does not change. I need to find two numbers whose product is +30 and whose sum is -13, which is going to be -10 and -3. So these guys right here, those are my magic little numbers that are going to do the whole trick in this problem. Now, some kids are like, well, Mrs. Stoltz, why didn't you do this on the previous slide when you had trinomials where a was 1? Why didn't we use this trick? Well, consider if a is 1, let's say you have x squared plus 4x plus 3, for example. Right? And again, I'll just put a 1 here to emphasize this. Technically, you are doing the a times c trick. So the very top number is going to be 3 times 1, which is still c. So it doesn't matter what c is, you're going to have c on the top because anything times 1 is itself. So it just saves you a lot of work if you know, oh, this criteria is met, I can be a little bit lazier and I don't have to do all that like a times c stuff. I can just write the magic number, find my magic numbers, and call it a day. Unfortunately, it's not going to be that easy for these because the criteria is not meant to use that shortcut. So what we're going to do once we have our magic two numbers is we're going to break b into the sum of those two numbers that you found. So what happens is I'm basically rewriting the problem. So I have 6x squared, but I'm not going to write -13. I'm going to write -10x plus -3x plus 5. So I broke b into the sum of my two numbers. Now, once you think for a minute, I have not changed the value of this problem. If I asked you to simplify this, you would get 6x squared minus 13x plus 5. That is the original problem. I haven't changed anything about this problem. I've just reformatted it and structured it so that I can factor it. So it still has the equivalent value that it had before, so I have not changed that at all. Why am I doing this? I'm doing this so that I can group, and this is where it gets its name. So I have 4 terms. I'm always going to have 4 terms. That's the whole point to doing it. And I'm going to group 2 and 2 together. Again, haven't changed the value of the problem. It's not now a FOIL problem. There's a plus sign separating it, so I haven't changed anything. Okay. But what's going to happen is I'm actually going to be allowed to factor out the GCF from each group. And then something cool happens when I do that. So between 6 and 10, I get 2. And I can also factor out an x. And that would leave me with 3x minus 5. Now for the next group, I typically like my x term to be positive, and right now it's negative. So I could fix that if I factor out a -1, because then I'll get 3x and -5. Now here's your safety net. These parentheses should always match up. They should always match up. If they don't, that's your cue. Oh crap, I made an error somewhere. So you gotta go back and find it. So look for those guys to match up. If they match up, should give you a boost of confidence that you're in the right direction and you're almost done. So all we have to do at this point is pair our GCFs together. So the 2x and the -1 will go together in their own little parenthesis. Now, I'm not going to write plus -1. I'm just going to write -1. All right. And then what we do is we keep one of our common groups. So they're the same, but you just keep one of them. So you're going to have a 3x minus 5. All right. And that is factored. And how would you know if you did this right? Foil it back out, and you should get this. So if you ever want to know if you factored it right, foil it. See if you got the starting problem. Right. So that is called factoring by grouping. So some things to realize. If A is 1, I don't need to do all this. You absolutely can do all these steps for whether A is 1 or not. But you're doing unnecessary work because it's always going to work out to be A plus the first number, or X plus the first number and X plus the second number. If A is not 1, you have to do this method. All right, so you can't use the little cheating method of just setting up the answer. All right. Now, some kids ask, they're like, well, why does that work? Like, what's going on here? So, okay, well, I didn't change the value, right? When I put the parentheses in, I didn't change the value. When I factored, I still didn't change the value because if you went ahead and distribute this back in, you get back to the beginning. So that's okay. The reason I can go from this step down to this step is if you think about it from a logical standpoint. All right. So if you have 2 groups of 3 plus 5 groups of 3, isn't that the same thing as saying you have 7 groups of 3? So if you have 2 groups of 3 plus 5 groups of 3, you can also say, you know what, I actually have 7 groups of 3. So you can totally pair these outside guys together and then just say that's how many groups of this I have. So it's kind of a logical reason as to why that works, but it's just counting groups. So if these are the same group, you can just count these together and that's how many groups of that item you have. Could be a little tricky to understand, but that's kind of the logic behind it. So I have 3 examples. I'm not going to do all 3 of them. I'm going to give you one to do on your own, but I will do 2 of them with you. So we'll do letter A first. All right, and you can see these are all those, A doesn't equal 1 scenario. There is no GCF. You have to do it this long way. All right, so I'm going to do my A times C. Again, the most important step, and that's the one kids forget to do, and that's a killer. So if you write 45 on the top, you're probably not going to find a magic pair that works, and then you're just not going to be able to do the problem. So actually, -90 is the top and 13 is the bottom. So I have to find 2 numbers whose product is -90, but whose sum is 13. Think of things that make 90. So 9 and 10, 45 and 2. We could do 30 and 3. If 30 is a factor, then 15 has to be a factor. So 15 times 6. Right, so it might take a little while to play with it. If you notice, it ends in 0, which means 5 has to go into it. So if I do 90 divided by 5, I get 18. And I'm looking, is there any way any of these pairs could make 13 in any possible scenario? So no, 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 no. Oh, 18 and 5 could definitely make positive 13 somehow. How could that happen? If 5 is negative. So let's try it out. -5 and 18. Let's see, does that complete the puzzle? They definitely multiply to make -90, and they definitely add to make 13. Got it. So sometimes you just need to list out pairs of factors for that top number and then look for a combination that could somehow get you that bottom number. All right. Next step, rewrite it. So I will no longer write 13. I will change it to 18 and -5. And it doesn't matter which order you write it in, you're going to get the same outcome. So again, I just changed 13 into 18 minus 5. It's still 13. We're going to do that so that we can group. So then I'm going to factor out the GCF, which would be negative x, which leaves me with positive 2x and positive 5. So we want to see if we can get a 2x plus 5 in this parenthesis. So between 18 and 45, you can factor out 9. And that leaves you with positive 2x, positive 5. So that's a sigh of relief. We got parentheses that matched up. That should happen. We didn't make a mistake, so that's great. Last step, we're going to pair up those GCFs. So negative x and positive 9. And we have 2x and positive 5. And now we have it factored. If I want to know if I did it right, I can FOIL it back out, but I am going to get this. All right, letter B. So again, we start by doing A times C. And remember, you guys, you can always do A times C for no matter what scenario you have. It's just you could keep track of your criteria and shorten your workload if you know the criteria rules. So it looks like I'll get negative 60 and 7. So I need to find my magic numbers that do the trick. So I know 4 and 15 makes 60. I know 6 and 10. I know 3 and 20. I know 5 goes into 60. So 5 and 12 could go in. And actually, I'm going to stop writing because as I'm writing them, I'm looking for numbers that could make 7. So no, no, no. But yes, 12 and 5 could somehow make 7 if 5 is negative. So if I use negative 5 and 12, oh yeah, they do multiply to negative 60 and they add to 7. Those are my magic numbers. So those are the only things that I really care about right now. So I have 4m squared. I'm not going to write 7. I'm going to break it into negative 5 and positive 12. We're going to group. And we're going to factor. So it looks like m, leaving me with 4m minus 5. And 3, leaving me with 4m minus 5. That's a good sign. And then we're basically done. And that's my answer. So what I'll do is I'll pause my video, I'll do the workup for C, and then I'll unpause it, and you can see how well that you could follow that. So go ahead and give C a try, and when you're ready, you can unpause the video. All right, so this one was tricky because you do get a big value as your top number and a small one for the bottom. So I know 21 times 12 may do 52, but there's no way that that makes 4. So here's what I kind of do when that happens. I think of what are some things that go into 21? What are some things that go into 12? Or what are some multiples of 12 and some multiples of 21? And I try to play with those numbers. So I knew that 7 would have to go in if 21 did. But 736 kind of gets me even further apart. So I tried something bigger than 7. I was like, well, you know what? 28 is a multiple of 7. Let me try 28. And 28 did work, right? But unfortunately, it didn't make 4. So I looked at the other way. I said, well, you know what? If 9 goes into it, then 3 does as well. So maybe 3 and 84, but that didn't work. So I just kept playing around with it. I tried another multiple of 7. I knew 14 was one, and I got 18, and I was like, oh, perfect. Those are 4 apart. So whatever pairs you guess is fine if it doesn't work, but use your factor knowledge and think, well, what are some multiples or factors of this number? Because they probably go into it as well. All right. So once you found those 2 magic numbers, excuse my bad handwriting, you factor out your GCF after you group it, and then you pair up them, and that's what you should get. All right, so congratulations, you survived your factoring refresher / new factoring tactics and all that, but that's kind of the grand scheme of the factoring world that we're going to be entering.